Okay. So last Thursday, we have discussed how to find the limit for a lot of functions, right? By looking at the graph, remember, right? Okay, so let me turn on the
No. Done. Do the bugs have about like 9?
okay, let me turn on the ebook, okay? I want to share the screen with you, okay? That's ebook. For now, we have to go to chapter 2, limits and derivatives. So this chapter is very important, as I told you, right? Because the limit is one of the central ideas in calculus, okay? We'll encounter this idea more than once, actually many times in the future, okay? It got to be, okay, now let's go to section, we have finished section 2.2, right? Now, let me share the screen, okay? Share the screen with you. Let me share the screen with you, okay? Share the screen with you. So, okay, screen right here. Okay, screen right here. Now we're in section what? We're in section 2.3, right? We're in section 2.3, okay? 2.3. Okay, we're in section 2.3. So we got to learn how to find out the limit by using what we call the limit laws by using algebra, right? In section 2.2, we use what? We use the graphs, we use the pictures, right? To see the limit, right? Remember, we have found how to calculate the left limit and the right limit and two-side limit, right? Now in this section, we have to learn something about the limit laws to calculate, to find the limit without using any graphs, right? So this is the topic in section 2.3, okay, in section 2.3. The title is calculating limits using the limit laws. So how many limit laws do we have, right? There are a bunch of limit laws, but they are very commonsensical, okay? Now let's take a look at these, okay, these. We have 5 laws, actually, okay? We have 5 laws. So let me, okay, look at first law, okay? This means what? You have 2 functions, right? Fx and what? Gx. Now you want to find out the limit of their sum, right? Let's go to what? The sum of their limits. Okay, this is very easy to remember, right? The limit of the sum equal to the sum of limits. Okay, now you know how to find the limit of fx, the limit of gx, x approach 3, right? You can find the limit of fx plus gx. Similarly, if we have what? The limit of the difference equal to the difference of limits. Okay, this is the law number 2. Now the third law is that C is constant. Okay, this C is constant. You can put a C outside. You will see the limit of fx as x approaches a. Easy to remember, right? Now the fourth is what? The limit was the fifth. The limit of quotient equal to the quotient of limits. Of course, you have to require that this denominator is non-zero, right? If the denominator is 0, then this does not make sense, right? So we have learned how many laws? 5, okay? And 5 laws. Okay, so there are 5 laws for calculating the limit. It's easy to remember. We have 4 operations, right? So the limit of their operations equal to the operation of their limits. Limit of sum equal to the sum of limits and so forth, right? So we have 5 limit laws, okay? So we have to use that to calculate the limit, okay? Now let's continue, okay? Let's continue. Okay, so remember, okay, we have 5 laws so far, okay? So far. Now let's continue, okay? Let's continue with, let me scroll down, okay? Now that's the name, right? We call it sum law, difference law, constant multiple law, product law, and quotient law. Right? So look at the number 4. The limit of a product equal to is the product of the limits. Okay, so they are easy to remember, right? They are very commonsensical, so easy to remember. Okay, you don't have to memorize them especially hard, right? Actually, it's easy to remember. Okay. Now, let's look at certain examples here. Okay, this is easy. Now, next is what? The power law. What does power law mean? The limit of the power function equal to what? The power of the limit. Okay, fxn is the nth power, right? So the limit of the power function equal to the power of the limit. Right? This is the so-called power law. What's next? This is number 6. What's number 7? The limit of constant equal to constant. C is constant, right? So the limit of constant equal to constant. Okay. Now this is limit of x, and x approaches a equal to a. That's very easy, right? Because you can what? You can sketch it, right? We have to learn how to handle this, right? We have this is x-axis, right? And then this is y-axis. Okay, this is y-axis, right? And this is the origin. Okay, now this function is what? Function is y equal to x, right? Right, function y equal to x. All right, so you can sketch what? 45-degree line, right? Y equal to x. Right, this is y equal to x. It's a straight line, 45-degree line, right? Not x equal to a. So suppose this is a, right? Okay, so tell me what's the y value? What's the y value if x equal to a? Tell me what's the y value here? X equal to a, what's the y value? What's the y value here for this point? What's the y value? It's also equal to a, y, because y equal to x, right? Okay, so for this point, if x equal to a, y also equal to a because y equal to x, right? So on this line, the y coordinate and the x coordinate are signed, right? Now let's look at the limit. Okay, let's look at the limit when x go to a from left and from what? From the right side, right? Two-side limit, right? Two-side limit. Now, if x go to a from left side, what's the y value will go to? The y value will go what? Will go up, right? Well, what? Will go to a. If x go to a from right, the y value will go down. Look at the picture, right? Will go down. Well, they will go to what? Go to the same a, right? So therefore, the limit of x as x approaches a is equal to a, right? Because look at the picture, right? X go to a from either side, right? The limit, one side limit is equal to a, the other side limit is also equal to a, right? They are signed, so therefore we have these. Okay, so got to remember the limit of x as x approaches a is equal to a itself. Okay, for example, please write down, okay, the limit of x as x approaches 9. 9, okay, this is 9, okay, 9. Equal to what? Tell me. Limit of x and x approaches 9. What's the answer here?
9.
What's the final answer?
9.
9, yes, thank you. Yes, 9, right. Thank you very much. Right? This is the rule number 8, the law number 8, right? Number 9. Okay, easy to remember, right? The limit of x as x approaches a equal to this number, right? Easy, okay, easy. So not hard, the math is easy if you understand, right? Now this is the limit of xn as x go to a, you can times n, right? By using the what? The product law and rule number 8, right? You can have an, okay? Easy to see, right? Easy to see. Now let's look at this rule number 9, right? Rule number 9. Now you have what? You have this is for the nth root, right? The limit of x is the nth root as x approaches a equal to what? Equal to a of the nth root, right? N is a positive integer, okay? So now you have the root law, right? This is the law number 11. The limit of the nth root of fx as x approaches a is equal to the nth root of limit of fx. You can put a limit inside, right? So find the limit, okay? So this is, we have learned 11 laws, right? 11 rules, okay? 11 rules. Now let's evaluate. Let's look at number 2, okay? Number 2. Evaluate the following limits and by using the limit laws, okay? So everybody please do number A, number B. It's very easy, okay? Very easy. Please find them. This is very easy. This is very easy. Please find it by using limit laws. Okay, let's do first, okay? Let's do first. Okay, let's do first. Let's look at the okay, now you want to find the limit of this one. This is what? This is a Kodiak polynomial, right? And x approaches 5. So how can we find this limit? Easy. You have what? This is the limit of the, this is difference, this is sum, right? By what? By the sum law and the difference law, right? You can do it term by term, see? Right? You can do it term by term, right? So we have this. What's next? What's next? What's next? You can what? You can 2 is constant, right? 3 is constant. So you can put outside, right? Put outside, right? Put outside. Now that's easy now. Why? Because the limit of 4 as x approaches 5 equal to 4. Because 4 is constant, right? And the limit of x as x approaches 5 is 5, right? So 3 times 5, this is 5 squared, right? To 39, right? To 39. So in the future, you can what? You can just put a 5 inside to evaluate the answer, right? So in the future, you can see that actually, what's the final effect? Final effect is that you can replace x by 5, right? In order to find the answer, see? Right? So the final effect is very easy. Final effect is nothing but what? To calculate this polynomial with x equal to 5. Okay, so therefore, we can find the answer, right? But for this problem, you have to what? You have to what? You have to do this step by step, right? Because this is instruction, right? You have to do step by step. So you have to write down. This is loss 2 and 1, right? This is loss 3. This is loss 9, 8, and 7, for example, right? But in the future, you don't have to write these. Okay, you just find the answer from here to here. Okay, right away to evaluate this limit, right? But for this problem, you have to follow the instruction, right? You have to do it step by step, okay, to get the final answer, right? The final answer is 39, okay, 39. So we have found number A. Let's look at number B, okay, number B. Okay, let's look at number B. See, this is number B, part B, okay? Now please do it by yourself by using the limited laws we have learned so far. Please do it by yourself, okay? Do it by yourself. You have several steps, right? In order to have the final answer, right? In order to. Okay, so let's do it by using the limit laws, right? This is the limit of what? Limit of two functions, right? Two functions. So this function over this function, right? So you have to use what? The law number 5. What's law number 5 mean? Quotient law, right? So you have to go to the limit of the numerator over the limit of the denominator, right? Now for the limit of the numerator, this is what? Polynomial, right? This is also a polynomial. Then you can do it term by term, just we have done this in part A, right? So what's the final effect? The final effect is that you can replace what? X by -2, then you find the answer, right? The answer is -1/11. Okay, so in the future, you can skip these steps, right? You can find the answer from here to here, right? So final effect is that you replace X by -2, right? And evaluate this rational function, right? To get the answer. All right, so in the future, you can skip these steps, right? But for this problem, you have to do it step by step because this is the instruction, right? Instruction. Okay, so we have found the answer. Okay, we have found the answer for the problem. Okay, for the problem. Okay, for the problem. So the answer is -1/11. Okay, so easy to remember, right? You have to use the various laws, right? But in the future, you can skip these steps, right? You can find the answer just by what? By replacing X by -2 in order to evaluate to get the answer, right? Why you can do that? Because you have used a lot of law, right? A lot of limited laws, right? All right. So much for this part. Okay. Okay. So much for this part. Okay. So this is note. Okay. This is note. See, right? If we let this, then F5. In other words, we would have gotten the correct answer in number 2A by substituting 5 for X, right? So this is so-called what? This is so-called direct substitution property, okay? This is that. Let's look at this, okay? So this is very nice, okay? So please pay attention to this, okay? So let me circle it. This will be heavily useful in the future, okay? So please remember this, okay? Please remember this. It's called what? Direct substitution property, or you can say DSP. What does it mean? If f is a polynomial or rational function and a is in the domain of f, then it's easier to find the limit. The limit of fx as x approaches a is just equal to what? Fa. See? Right? So you can find the limit right away, right? Without what? Without going through these steps, right? Unless the problem asks you to use these, to ask you to write down all the steps, right? But in the future, you can use what? You can use direct substitution property to find the limit in a few seconds, okay? In a few seconds. That's the meaning, okay? That's the meaning for this, okay? For this, okay? Okay, so let's look at this direct substitution property once again. F is a polynomial or rational function. A is in the domain of f, right? Then how can we evaluate the limit of fx as x approaches a equal to fa? Okay, so all you have to do is to what? to evaluate f at a, right? To get the answer right away, right? So that's called the direct substitution property, okay? Direct substitution property. It's very easy, right? Very easy to remember, right? So the limit of fx as x approaches a is just equal to what? F8. Okay, easy to remember, right? Easy to remember. So this is very nice method, right? It shows that you can find the answer very fast without what? Without going through all these long steps, right? And there's a problem asks you to follow these, right? Follow me to write down all these steps, right? By using called the limit laws, right? So we have finished this part. Any questions so far? Any questions so far? So we have finished, okay? The so-called direct substitution property, okay? Now, let's look at these. Let's look at example 3. Okay, now we want to find the limit of x squared minus 1 over x minus 1 as x approaches 1. Now please find this limit by yourself. Can we use direct substitution property for this? Ask yourself. Can we or we cannot?
We can't.
Why you cannot? Because
it'll make the denominator
if you put a
0.
1 inside, let's see what happens. Yes, very good. That's the key. That's the inside, key inside, right? You put a 1 inside, right? Because x go to 1, right? Put 1 inside, you have these. Right? It becomes what? It becomes 0 over what? 0. But what does 0 over 0 mean? Does not make sense in mathematics, right? So for this problem, you cannot use what? You cannot use direct substitution property anymore. The reason is that if you put a 1 inside, it becomes 0 over 0. 0 over 0 does not make sense because the denominator is 0. So what should we do? Right? You cannot use DSP. DSP means direct substitution property. We cannot use that anymore. You have to use what? We have to use algebra to simplify. Okay. Now let's look at these. You have to simplify by using algebra. What's x squared minus 1? You can factor. What's x squared minus 1? Tell me. Is x minus 1 times what? X plus 1. All right, and over x minus 1. Then you can what? You can simplify. See? They're gone. Right? Same numerator, same denominator, right? They're gone. So this rational function can be simplified, right? So let me continue. Okay, let me continue. See here. Here. See? Let's look at these. Okay, let's look at these. You can factor the numerator, right? So it becomes x minus 1 plus 1 over x minus 1. So they're gone. See, they're sign, right? They're sign. Right? So therefore, they're gone, right? So what's left? Is x plus 1, right? Then you can use what? Then you can use so-called what? Direct substitution property. Why? Because this becomes a polynomial, right? Polynomial. Easy, right? You put a 1 inside, 1 plus 1 is 2. So that's the final answer. See? Right? After you simplify x minus 1, they're gone, right? So what's left is x plus 1. Right? Then you can use what? DSP, right? Because it's a polynomial, right? 1 is inside domain, right? So 1 plus 1 is what? 2. So we have finished. See? We have finished. Right? We have finished. So the answer is 2. Okay, so here you have to use what? We have to use algebra. If we don't use algebra, then we cannot solve it. Right? We cannot solve it. So algebra here is very important. Okay, it's very important in this section, at least. Okay, very important. Now let's go to next example, okay? We go to next example. Okay, so in this problem, we have found the answer, which is 2, right, by using algebra, okay? Let's look at another example. This is easy. It's just look at the graph, it's easy. Now let's look at example 5. Please do it by yourself. Evaluate the limit as h approaches 0 of 3 plus h squared minus 9 over h. First, you want to use what? You want to use DSP, direct substitution property. See what happens. Okay, see what happens. H go to 0, you put 0 inside, right? You come what? 3 plus 0 square, right? Minus 9 over what? Over 0. What's this? 0 over 0, right? Again, you have a question mark here. What's 0 over 0? We don't know. Because these are not make sense in mathematics, right? So we cannot use what? We cannot use DSP, direct substitution property for the problem. Again, you have to do what? You have to do algebra. So please solve these. You have to simplify the numerator, right? And then what? Then continue, okay? Please solve these. Please solve these by yourself. Okay, limit of this function as h approaches 0. Please do it. Don't wait. Okay, don't wait. Do not waste your time. Okay, you have to solve these to find out the answer. All right. So remember, DSP does not work here. Okay. You have to do algebra. Okay, you have to add. So remember, okay, direct substitution property does not always work, right? For this type of problem, we got to do algebra first to simplify. Okay, so let's look at the answer. It's very easy to simplify, right? See, you have to expand, right? So let me write down the formula. This is a high school formula, right? Very easy to remember formula. Let me write down, okay? This is a plus b, right? Square equal to what? What's a plus b square? Tell me. Is a square plus b square? Of course, it's wrong, right? So what's the right answer? A square plus what?
2ab.
2ab, right? Yeah, 2ab. Don't forget the middle term, right? Plus what?
B square.
B square. That's the right answer. Right, that's the right answer. So if you write, someone say, oh, that's easy. A plus b square is equal to a square plus b square. Naive formula. Unfortunately, that's wrong. Okay, a plus b square is not equal to a square plus b square. That's the wrong formula. The right formula is right here, right? It's the right formula. Okay, so don't use the wrong formula, right? Otherwise, people will laugh at you. You say, oh, a plus b square is a square plus b square, but that's a terrible mistake, right? It's a terrible mistake. The right formula is right here. See, a plus b square is a square plus 2ab plus b square. It's easy to see why, right? What's a plus b square is what? A plus b times what? A plus b, right? Right? A plus b squared is a plus b times a plus b. Now you can do it. How many terms? We have 4 terms, right? We have 4 terms. Okay. You expand, right? You have what? A times a is a squared. You have AB plus BA. They are same, right? 2AB and B times B is B squared. Therefore, you have 4 terms, right? And AB and B are same. You can combine them into 2AB. All right. So this is wrong formula. This is right formula. Okay. Now you can simplify. Please do it. You have to expand, right? Expand. Okay. Expand these. Right, by using this formula, right? This is A is 3, B is H, right? Now do it. Please simplify. You got to learn how to handle the limit by using this method, by using algebra, okay? Everybody should learn in this class how to find the limit by using algebra, because DSP does not work in this case anymore, right? Please do it. You can always simplify. If you cannot simplify, then the problem becomes very complicated, right? But so far, we can do it by using algebra, okay? Easy, okay? Easy. Not hard at all. Not hard at all. See, a squared is 9, right? 2 times 3 times h is 6h. And h squared is h squared, right? Minus 9 over h. So 9 minus 9 is gone, right? So the numerator becomes what? 6h plus h squared over h. Now h is the common factor here. Let's see. Right? H is the common factor. You put h outside, right? So inside is 6 plus h. Now you can what? Cancel out h, right? Cancel out h. Now what's left? You see, right? Now we can use what? Now we can use direct substitution property, right? And h go to 0, this is a polynomial of h, right? So the answer is 6, right? Okay, the answer is 6. See? Right? The limit of 6 plus h as h approaches 0 is put 0 inside by using what? DSP, right? 6. So we have found the answer. Okay, 6. Okay, 6 is the final answer. Right? 6. Okay. So for this limit, we cannot use what? DSP right away, right? We have to do algebra. Simplify first. Then we can use what? DSP, right? To find the answer, which is 6. Okay. Okay. Now we have to do more examples in this section. Okay. So let me stop this for a few minutes. Okay. To ask yourself, do you feel comfortable with this? You have to know by yourself, right? Do you feel comfortable with this? If you feel comfortable with this, I will continue, okay? Otherwise, let's just review some basic algebra, okay? So here you have to use what? Use algebra in order to handle the simplification part, right? Like a plus b squared equal to a squared plus 2b plus b squared. Tell me the formula for a minus b squared. What's the formula for these? Carson, H. Carson.
Sorry, what is it?
What's the formula for a minus b squared? You know, a plus b squared is a squared plus 2b plus b squared. What's the formula for a minus b squared? Remember the formula?
No, could you say it?
Okay, let me share screen, okay? Okay, let me tell me the formula for this. Carson, tell me the formula for these. What's a minus b squared? What's a minus b squared? We learned how to handle a plus b squared. But what's a minus b squared? Remember the formula?
No, I don't remember it.
Okay, you got to remember, okay, for this section, okay, formula is this. B square minus 2ab, okay, plus what? B square. That's the right formula. Okay, that's the right formula. Please remember this, okay? Okay, we have to use the formula many times, okay? So a minus b square is a square minus 2ab plus b square. Now what's the formula for this? How can we factor a square minus b square? How can we factor? What's a square minus b square? How can we factor this? Carson, can you remember the formula? How to factor a square minus b square? You have two factors, right? What are they? Remember? What are they? How to factor a square minus b square? What?
A plus b and a
I
minus
cannot hear you.
a
Yeah,
plus
thank you very
b
much.
and a minus b.
That's yes, very good. A plus b times a minus b. Very good, Carson. Thank you. Right? The answer is a plus b a minus b equal to a square minus b square. So we have to use this formula, okay, in this section. Okay. Now let's remember this formula because we have to use them, right? You cannot afford to forget them. Okay. If you forget them, then you'll be very difficult for you to do any problem in this section. Okay. So you got to remember these important basic formulas, right? We have learned how to calculate a plus b square. Now we learn how to find out a minus b square and how to factor a square minus b square, so on and so forth, right? All these formulas will be very important in this section, okay, in this section, right? Now let's do this problem. Let's solve this, find limit for these. Okay, find the limit for these. Find the limit. Plus 9 minus 3, and the denominator is just t squared. Okay, t squared. T squared t. Yeah, t squared. Okay, so the numerator is square root t squared plus 9 minus 3, and the denominator is t squared. First, can we use direct substitution property for this problem or not? Can we or we cannot?
We can't.
You put t equal to 0 inside to find out what happens for these. Very important for you to know why you cannot use this method, okay? Put t equal to 0 inside, let's see what happens. What's 0 square? 0 plus 9 is 9. Square root 9 is what? 3. 3 minus 3 is 0, right? 0. T equal to 0. 0 square is 0, right? So it becomes 0 over 0 if you want to use DSP, direct substitution property, right? So this method won't be useful, right? Because it will give you only 0 over 0. You cannot have the answer, right? You cannot have the answer. Now, what should we do? By using what? By using algebra, right? So algebra is so important in this section, right? So here, the method is called what? Rationalize the numerator. See, this is the method, okay? Okay, the method called rationalizing the numerator. This is important method in this section, okay? You got to know how to solve this kind of type of question, right? It's called rationalizing the numerator. Okay, rationalizing the numerator. Okay. Now you can see how to do that, right? The numerator, right? So it's square root t squared plus 9 plus 3, right? And you have this is actually this is what? Right? Because you cancel out, this is 1, right? So times 1, nothing has been altered. right? You plus 0 or times 1, it's legitimate, right? Because times 1, the function cannot be altered. You plus 0, the function cannot be altered. It's the same function as the original function, right? So you can times 1, you can add 0. It's fine. Why I want to do that? Because you can what? You can see that the numerator is z times z, right? You can use what? You can use the famous formula, right? It's a minus b. I just erase, right? And a plus b, as Carson said just a few minutes ago, right? What's that? Go to a squared minus what? Right? Carson, you just said this a few minutes ago, right? A minus b, a plus b is just a squared minus b squared, right? The formula going backwards, right? Now you can see that this is a minus b times a plus b, so equal to a squared minus b squared. So square root of t squared plus 9 squared is just t squared plus 9. The square root and square cancel out, right? And the 3 squared is just 9, right? And the denominator just z times z, right? Now you can simplify. See, 9 minus 9, they're gone, right? So what's left? It's t squared. You see t squared, right? You can simplify, right? Cancel out, right? Now it becomes what? Easy. The numerator becomes 1, and the denominator is just this, right? Now you can use what? You can use DSP, right? So the answer is put a 0 inside, right? So this is 0 squared, 0 plus 9 is 9, square root 9 is 3, right? The answer is 1, 6. Okay, 1, 6. So exact answer is 1, 6. Okay, so we have found the limit. If we use DSP right away, you get 0 over 0, right? Now we have to do what? Algebra by using the method of what? Rationalizing the numerator, right? You simplify, you have the answer 1, 6. Okay, 1, 6. So we have found the limit for the type. Okay, for the type of the limit, right? Is 1, 6 by using so-called rationalizing the numerator method, right? So this is a very useful method in this section. Okay, the answer is 1, 6. I hope we have the same answer. Let's look. Let me look. See, 1, 6, right? 1, 6. Okay, 1, 6. Okay. Now we have learned this in last section, right? This is two-side limit. This is left limit and this right limit, right? Two-side limit equal to L if only if what? The left limit and the right limit are equal. They are both equal to L. Okay. This is what we learned in last section, right? This is not nothing new here. Okay, nothing new. Now show this. Show this. So the limit absolute value x as x go to 0 equal to 0. How can we show this? Okay, you got to learn how to show it, right? By using so-called. Okay, now you got to write down. You got to know for the absolute value x is a piecewise defined function, right? So this is what? If x is non-negative, this is x. If x is negative, it becomes negative x. Okay, so remember, okay, absolute value x can be written in two pieces. One is for positive piece, the other is for negative piece, right? If we want to sketch, it's a sketch, okay? Okay, this is x, right? This is y, and then this is the origin. Right, for x non-negative is y equal to x, right? The 45-degree line. Okay, for x is negative, y equal to negative x, right? This is this. Okay, so this is what? A line, okay? A line, not a curve, okay? A line, okay? A line. Now this is what? This is like a V, right? Like a V, okay? So this is the graph for y equal to x. Okay, we learned this in math level 26 or math level 25, right? The graph for this function y to absolute value x is a V-shaped curve, right? This is y to x for x non-negative. This is y to negative x for x negative, right? So this is the shape for this function, okay? For this function. Now you have to what? You have to find the left limit and the right limit, because the left function and the right function, they look differently, right? See, they look different, right? See, this is y to x, this is y to negative x, right? So therefore, you have to know how to find what? The right limit and the left limit. Okay, now let's do it. Let's find the right limit first. Okay. The notation for right limit, okay, limit as x approaches 0 from the right side, right? X. You got to know, you got to learn how to write down the answer mathematically, right? This is the limit of absolute x and x go to 0 from the right side. Okay, this is from the last section. Now you can continue, right? Equal to the limit as x approaches 0 from the right side, right? Right side. Now x go to 0 from the right side means what? X is non-positive, right? So this is, right? The function becomes x. Now you can see that and x go to 0 from the right side, the y value will go to 0, right? So the answer is 0. Okay, so we have found that the right limit is 0. How about the left limit, right? So you have to know how to write down, right? The limit as x go to 0 from the left. It's 0 minus, it means from left, right? Absolute value x. Okay, in this case, equal to the limit x approaches 0 from the left side. So what's the function if x approaches 0? From left side means x is what? X is negative, right? So in this case, the function becomes what? Becomes negative x, right? Becomes negative x, see? Negative x, okay? Okay, become negative x because x goes to 0 from left side, x is negative, right? So if x is negative, the function is negative x, right? Now you can see that if x goes to 0 from the right side, the limit goes to 0, right? Go to 0. Okay, now you can see that the right limit and the left limit, they are both equal to 0. They are same, right? So therefore, the two-side limit exists and equals to the common value here, right? So please write down, okay? Equal to 0. So we have finished. The answer is 0. Okay, we have finished. Okay, so we have found the limit as x approaches 0 for absolute value x, right? Which is 0. By using what? By using the right limit and the left limit. They are both equal, right? They are both, I mean, they are equal to each other, right? So therefore the answer. Why I want to use the left limit and the right limit? Because for this problem, the is a piecewise defined function, right? It's a piecewise defined function. So therefore, you have to use what? Two pieces, right? The right piece by using the right limit, the left piece by using the left limit. Because the right function and the left function, they are not the same function, right? This is y to x, this is y to negative x. They look not same, right? You cannot use the same formula, right? This is y to x, this is y to negative x. The formulas are different, right? So therefore, you have to use what? The right limit and the left limit. You have to deal you have to cope you have to handle the right limit and the left limit separately, right? That's the key part for these, okay? That's the key part. Okay? So sometimes you do need the right limit and the left limit. The reason is that this is a piecewise defined function, right? So we have found the answer. The answer is 0, okay? Easy, as long as you know how to handle it. Okay, so let's look at, see, right? The right limit is 0 and the left limit is also 0, right? So therefore, by using above theorem, right? The two-side limit is what? It's 0. So we have found the answer, right? It's 0. So we have done it, right? Okay, now this is the picture. Don't forget that, okay? The picture for what? Absolute value x, right? It's a V, remember? It's a V-shaped curve, as I told you, right? It's a picture, right? Easy to remember, right? How to sketch? You have to sketch two pieces, right? This is the right piece, this is the left piece, right? You got to remember how to sketch these simple functions. Okay, now do this. Show that this limit does not exist. Please do it by using right limit and the left limit. Do it by yourself. Do not look at the answer. Okay? Do not look at the answer. This is number 8 in this section. Okay. Show that the limit of absolute value x over x and x approaches 0 does not exist. Show it, please. Here you got to use what? You got to use the right limit and the left limit because this is what? Absolute value function. Whenever you have absolute value function, you always to use you what? You always to consider. Usually, okay, you have to consider the right limit and the left limit. Okay, please solve these. Okay, show that the limit of absolute value x over x and x approaches 0 does not exist. Okay, not every time the limit always exists, right? For this, the limit does not exist. Okay, please solve these. Do not waste your time. Everybody, please do it by yourself. Okay, it's very important for you to practice, right? If you don't, then you will not know how to handle this in the quiz for this week. We have another quiz on Wednesday. Remember, time goes fast, so you got to do it. You got to finish the homework as soon as possible. You cannot just wait and waste your time, right? You have to show this limit does not exist. Okay, you have to show this limit does not exist by using the right limit and the left limit, and convince yourself that the right limit and the left limit are not equal to each other. So therefore, the limit won't exist for this problem, right? The idea is very simple. So all you have to do is to find out what? The right limit and the left limit. Okay, then convince yourself that they are not signed. So therefore, the two-side limit does not exist, right? Does not exist. Oh, have you received my email message about the Math Tutor Center? Let me share the screen with you. Okay, let me find out something. Okay. Let me share the screen with you. What's our schedule here? Here, see? This is the Math Tutor Center schedule. Okay, I sent you, look at the email I sent you in the morning, right? About this, okay, about this. This is what? Math Tutor Center, right? The opening starting this week, okay? So today is Monday, right? So it starts today, okay? It's open 5 days a week from 8 a.m. to what? To 8 p.m. See, it's very long, right? From 8 a.m. to 8 p.m., okay? So you can go there. You see that you can what? Click on the name to join the live tutoring session by Zoom, okay? So whenever you need help, you can go there you can go to the Math Tutor Center, right? You just what? You just click on name, right? And the tutor will help you, okay? Our TA's name is Joseph what? Joseph Cruz, right? Let me take a look at his schedule, okay? Let me take a look at his schedule. See? What's his schedule here? Okay, so see he will be here Monday from 12 to 1, right? Cruz, see, right? Cruz. And from 1 to 2, right? Monday. Tomorrow, if you need help, you can also see he will be here tomorrow from 12 to 1, right? Cruz, right? Cruz. Also, he'll be here tomorrow from 1 to 2, right? So you can see him tomorrow also, right? And also you can see him on what? On Wednesday from 12 to 1 and from 1 to 2, right? And also on Thursday, right? And also on what? On Friday. So he'll be there every day, okay? So please go there to seek help if you have any problem with your homework assignment, for example, right? If you don't have time for Cruz, then you can go to any tutor you want, right? Because for example, if you don't have time in the time spot, you can go to another tutor, right? So there are a lot of tutors available, right? See, from 7 to 8, you have Steiner from Monday through Thursday, right? So please use that. You don't have to pay any money, right? It's free of charge, okay, free of charge. So please use that because you don't want to wait until the last minute, right? If you wait until the last minute, you will be what? You will be too late, right? So don't do that, okay? Don't do that. Do not wait until the last minute, okay? Because you want, if you want help, please go to Math Tutor Center to find a tutor, and a tutor will help you by Zoom, okay? By Zoom. It's very useful, okay? Very useful. Okay, so let me close this off because we don't need these. Okay, now let's continue. Okay, continue with these. How to show this limit does not exist. Remember, I asked you to show it, right? How to show this? By using the right limit and the left limit. Don't forget that, okay? It's very important for you to understand how to find the answer by using the right limit and the left limit, right? Okay, now let me solve it for you, okay? Solve it for you. Now let's find the right limit first, okay? Find the right limit. Your screen sharing is paused. I don't know what happened for the screen sharing. You share. Here. This one. Okay, this one is can you see it? Okay, very good. Okay, very good. Okay, let's find the right limit first. Okay, right limit is this. Please write down. If you don't know how to solve it, please write down. Okay, x go to right. This means x goes to 0 from the right. The function is this, right? The function is right? Function. Now equal to what? You have to simplify, right? Go to the limit as x approaches 0 from the right side. See, x goes to 0 from the right side. This is positive, right? So the numerator is just x, right? Over x. So these cancel out, right? So it becomes what? It becomes the limit x approaches 0 from the right side of what? Of 1. 1 is a constant, right? So the limit of 1 is equal to 1. Okay, so now we know the right limit is 1. Okay, now let's look at the left limit. So the notation is this, okay? X go to 0 from the left, right? Function is sign equals to value x over x, right? Now let's continue. Limit as x go to 0 from the left. So x goes to 0 from left, x is negative, right? So what's absolute value x in this case? Is negative x, remember? On the left side, right? So over x. Now x gone, right? So it becomes what? It becomes the limit as x approaches 0 from the left side, 0 negative, right? The function is what? Inside is negative 1. What's the limit of negative 1? Equal to negative 1, right? Now you can see, are these same? Are these same? 1 and then negative 1 are not same, right? So the right limit is 1, the left limit is negative 1. These are not same, right? Not same. Right? So therefore, the limits are not exist because the right limit is 1, the left limit is negative 1. They are not same, right? So therefore, we have shown that the limit of this function does not exist. Easy, okay, easy. Okay, so for this problem, the right limit is 1, the left limit is negative 1, right? They are not same. They are distinct values, right? So therefore, the two-side limit does not exist. Okay, so we have finished. Okay, we have finished. Okay, take a look at that. Right, the right limit is 1, the left limit is negative 1, right? They are not same. So therefore, the two-side limit does not exist. Okay, this is the picture, right? This is the picture. This function is not defined at x equal to 0, right? The right side, the function is 1. The right side, the function is negative 1, right? So therefore, the right limit is 1, the left limit is negative 1. They are not same, right? So therefore, two-side limit at 0 does not exist. Okay, does not exist. So we have finished. Okay, we have finished.
I got a question.
Okay. Yes. Okay. Hold on. What question you have?
Why on the graph
question you
that they
have?
both are on the graph? Why they both are open?
Oh, because the function is not defined at x equals to 0.
Oh,
Right? It was 0 value x over x. What's the domain for this function? All real number except what? 0, right? So that's why you have a small circle there, because this function is not defined at x equal to what? 0. Right? The function is defined everywhere except what? 0. Because absolute value 0 over 0 does not make sense, right? Yes, does not make sense because for any function, the denominator should not be equal to 0, right? That's why you have a small circle there. Yes, that's why. Thank you very much. That's a very good question. Okay, so time is 7:37, so we can stop here. We almost finished, right? We almost finished this long section, okay? This long section. Any questions so far? Any question? If you don't, you can leave. If you have any question, you can stay to ask me, okay? I will see you tomorrow.